Welcome to video 5.3f, another proof involving parallel lines. So this is example 5. I'll mark up the givens as we go along. So it says AB is parallel to DC. So once again, I do like to extend those parallel lines. AB is congruent to DC. So I'll have AB congruent to DC. BF is congruent to ED. I'll go in blue here. So BF is congruent to ED. I'll just say that those blue segments are congruent. Maybe I'll put a little tick on each of them. AE is perpendicular to BD. AE is perpendicular to BD. I'll put the you can put the right angle mark on either one, but I'll just put it there for now. All right, I want to try to prove that CF is perpendicular. Okay, so I guess I'll just say, try to get that to be perpendicular right there. Okay, there's a couple ways of doing this proof, but one thing I want you to note is I'm given a BD perpendicular to AE, and I want to get BD perpendicular to CF basically. So if I could get these two things to be parallel, I would be done. Because I know, hey, if these two things are parallel, if BD is perpendicular to one of two parallel lines, then BD is also perpendicular to the other parallel line. So that's one of those oddball things at the end of the theorems that I listed before. Let's try to do that. Okay, so really now, I want to get these to be parallel, if possible. All right, if I want to get those to be parallel, it would be great if I had, well, it looks like what I could do is maybe try to get these two angles congruent. These two angles are on the outside, and on alternating sides, those are alternating exterior angles. So if I could get those angles to be congruent, then I could get those lines to be parallel, and then I could do that perpendicular theorem I was mentioning before. Okay, to get those angles to be congruent, maybe I could try to get the triangles to be congruent. So those are the two triangles I'm going to be looking at. Right off the bat, I've got a side with a side. I've got some segment subtraction I could do. So I've got this in common, so I will end up being able to get that to that. And then I had the parallel over here. I'd be able to get this angle to this angle. Those are on alternating sides of that transversal, and on the interior those green parallel lines. So it looks like I'm going to be getting some SAS. Okay, so now I have some direction. Get those triangles congruent by SAS. Get those corresponding angles congruent by CP/CTC, get those lines parallel, and then the perpendicular. And I'll talk about another way that you could have done it once I get there. Okay, so now I have a game plan. Let's do it. So I'll start with this statement right here. AB is congruent to DC given. That was my side. Now I'm going to go with my angle. So my angle came from that parallel. So AB is parallel to DC, that was given, and from that I got that angle. I'll use three letters. Angle ABD is congruent to angle, what shall I call it? I'll call it CDB. And that would be if parallel, then alt interior angles congruent. So that would be my angle. And then they gave me those big blue segments. That was right here. So that was BF was congruent to ED. That was given. Then I'm going to subtract that common segment and obtain BE to be congruent to DF. If a common segment is subtracted from congruent segments, then the difference is congruent. We'll just say segment subtraction. Now the triangles by SAS. The angle that I care about is this one, so let's list the triangle AEB. AEB is going to be congruent to triangle, I'll go DFC. Let me just double check that. CFD, sorry about that. And that would be by SAS. Okay, now I can get the angles. So I can get angle AEB to be congruent to angle CFD by CPCTC. So now I've got this angle here to be congruent to that angle there. So now I can get these blue lines to be congruent. One other way to do it would be say, these angles are congruent. I could say if perp then right and then the right thing, but I want to try to use this theorem. So now from that statement, I'm going to say line AE is parallel to line CF if alternate exterior angles congruent, then parallel. Then I'm going to say that I had that perpendicular statement there. AE is perpendicular to BD. That was given. So now, basically I've got that theorem. Hey, I've got two parallel lines. I've got BD being perpendicular to one of them. So then BD will also be perpendicular to the other. So I can say CF is perpendicular to BD if, I'll say if perpendicular to one of two parallel lines, then perpendicular to other line. However you want to word it, something to that effect. So there you have it, how to do another proof with parallel lines and really using the perpendicular theorem.